Hello friends, watch this project AI Diabetes Detector. Here we can predict the diabetes probability. So let's enter the values: age 34, gender male, BMI let it be 24, BMI category let it be obesity, let the systolic be 99, let the diastolic be 100, let the BP category be elevated, let the cholesterol be okay 234, let the cholesterol category be high and glucose value be 150. So let's submit and check how much diabetes probability is there to the person. So here you can see we got the diabetes predictions 45%. So with this model we can find the diabetes probability and it gave 99% accuracy. And to go back, click on that and you will return to the index page. Let's start to work on the project. So we will move to Kaggle notebook. Here we will develop the model with scikit-learn library and decision trees. So before developing the model, first we need to know about decision trees. So to learn about decision trees, its advantages and disadvantages and its matrices, let's move to Notepad. Decision trees. A decision tree is a supervised machine learning algorithm used for classification and regression tasks. It mimics human decision making by breaking down a dataset into smaller subsets using if-else like rules based on feature values, ultimately resulting in a tree structure. In the tree, at each node represents a feature, each branch represents a decision rule, and each leaf represents an output, that is level or prediction. After this, we will discuss about matrices used in decision trees. So the first matrix is Gini impurity. This is used in classification where that is equals to 1 minus pi square plus p2 square plus p3 square up to pc square, where pi is the proportion of samples belonging to class I in the dataset D and c is the total number of classes. And in regression we use MSC, that is mean square error, and which is equals to 1 by n times y1t minus y1p whole square plus y2t minus y2p whole square plus dot 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 plus ynt minus ynp whole square, where n is the number of samples, t is the target values, and p represent predicted value. After this, we will discuss on advantages. The first advantage is easy to understand and interpret. The second advantage is handles both numerical and categorical data. The third advantage is requires little data pre-processing, that is no scaling or no normalization is done. And the fourth advantage is it can model non-linear relationships. And the fifth advantage is it works well with small to medium range datasets. After this, we will discuss on disadvantages of decision trees. The first disadvantage is the decision trees are very unstable because small change in data leads to a different tree structure. The second disadvantage is it follows greedy splitting, which may not give globally optimal tree, but it provides locally optimal tree. And the third disadvantage is it gets biased with imbalanced dataset. After this, let's implement the decision trees. To implement, let's move to Kaggle notebook. So this is the Kaggle platform where I have implemented this diabetes probability prediction using decision trees, and for that I am using a dataset available in the Kaggle platform, and I have added the dataset to the dataset section, and with the button add input I have added, and similarly you can also add the dataset with add input. And if you have the data in your local system, you can upload. Okay, after that we will import the required libraries like Pandas, NumPy, matplotlib, seaborn, joblib and scikit-learn. The Pandas is for data manipulation, NumPy is for numerical calculations, matplotlib and seaborn are for data visualization, joblib is to shape the model, and from scikit-learn we are importing decision tree regressor to implement decision trees. Then we have train test split to split the data into two sections, train and test. Then we have column transformer to pre-process all the columns simultaneously. Then we have a pipeline to make a pipeline between preprocessor and the model, and then we have standard scaler to scale the data into -1 to 1. Then we have min max scaler to scale the data into minimum value to maximum value of the column. Then we have ordinal encoder and one hot encoder for categorical data pre-processing. Okay, so ordinal encoder is used when we have categorical data that can be ordered in a rank. One hot encoder is used when we can't order the data present in the column. After that, using the read CSV method and copying that path and pasting that path in the read CSV method, I am reading the data frame in the df variable. After that, to see the first three rows, I have implemented head method with df. So let's run it. Oh no, we got an error, that is we have not imported it. So let's rerun it. Yes, it is imported now. Now let's rerun second cell. Now you can see we got 3 rows and 3 columns. One is age, gender, BMI category, systolic, diastolic, blood pressure category, cholesterol category, glucose, and diabetes probability. Diabetes probability is our target feature, and after that we need to remove duplicates if they are available and remove nulls if they are available. So to remove duplicates, we have drop duplicates method. When we apply that, it will remove duplicates, and inside it I have passed two arguments, in place equal to true and ignore index equal to true. In place equal to true will modify the original data frame, while ignore index equal to true will reorder the indices. After that, I am using drop NA method to remove nulls, and again I have passed same arguments, that is in place equal to true for modifying the original data frame and ignore index equal to true to reorder the indices. After that, to see the information about the data frame, I have used info method. So let's run the cell and check out the information. So here you can see in total we have 10,000 entries, 0 to 9,999, and we have in total 11 columns, and these are the names of the columns. These are the non-null counts of the columns, and these are the data types of the column. So here you can see in total we have 4 float 64 data type column, then 3 int 64 data type column, and 4 object data type column. So after this we will do exploratory data analysis. So in exploratory data analysis we will plot the count plots for categorical columns. So let's first take out the categorical columns. To take out or select the categorical columns, we have a method select the types. It is a method which will return as categorical column or numerical column based on the include argument, and when we use columns attribute, it will give the list of columns that is stored in categorical columns. Then I have used number of columns equals to true and number of rows equals to length of categorical columns divided by number of columns, and then we have created some subplots with a figure size 10 and 8. Then I have given some space between plots in horizontally and also vertically, then iterating over all column with a for loop. After that, selecting a subplot with plt.subplot method, passing the number of rows and number of columns, then using the count plot method of Seaborn library, plotting the count plot for the column. So here I have passed x equal to col, that is the column, and data is retrieved from data frame, and then we have x ticks rotation equal to 45. That means the ticks will be rotated to 45 degree. Here you can see we got the plots. So in gender we have male and female almost nearly equal, and in weight we have overweight, obesity, underweight, and normal weight. So here obesity and underweight are having highest values, while underweight and overweight are having lowest value. Then we have blood pressure category. Here hypertension stage 2 has highest value and elevated has lowest value. Then for cholesterol category we have highest value for high and lowest value for normal. After that we are splitting the data into train and test with the method train test split. So first of all we need to select the features and the target column, and that will be saved in X and Y. So I'm dropping the diabetes probability column, that is our target column, and retaining all the features in X, while only saving the diabetes probability in Y. After that, using train test splitting and XY with test size equal to 0.2, that means 20% of the data will be reserved for test purpose, and then having random state equal to 42 to regenerate the same output from the train test split whenever it is re-executed. After that, the splits are divided in x train, x test, y train and y test. So with this we have splitted. Then let's see the shape of x train and y train. So here you can see we have 8000 rows in both x train and y train, and also 10 features in x train. After this, we need to pre-process the data. So to pre-process whole data, I mean whole columns simultaneously, we have column transformer. So column transformer is a method which is useful for pre-processing all the columns simultaneously. Here it takes 3 arguments, namely transformers, reminder and sparse threshold. Transformer will take list of tuples as value, and inside each tuple we will have an identifier, then an instance of preprocessor, and then list of columns to which the preprocessor will be applied. And I have used standard scalar for integer values, min max scalar for floating point values, and then we have one hot encoder and ordinal encoder. So in one hot encoder I have used 3 arguments, drop equal to first to drop the first output from the one hot encoder, then handle unknown equal to ignore out the unknown values encountered by the one hot encoder, and sparse output equals to false. The third argument, it won't make the one hot encoder to result sparse output, and we are applying the gender column to one hot encoder. Then in ordinal encoder we have passed an argument categories. The categories is nothing but list of unique values present in a column. So here we have applied BMI category, blood pressure category, cholesterol category. The main difference between one hot encoder and ordinal encoder is if we can give some rank to the values present inside the column, the unique values present inside the column can be arranged with rank. That means we can apply that categorical column to ordinal encoder. If we can't give any rank to the values present inside the column, like for gender case we have male and female, so we can't assign rank 1 to male and rank 2 to female. That's why we are using one hot encoder for that. After that we have remainder equal to pass through, so that the remaining columns will be passed easily. Then we have sparse threshold equal to 0, that is not to result sparse output by the categorical columns or numerical columns. So here we got the column transformer. After that we need to build model. So to build model, we are creating a pipeline between the preprocessor and the decision tree regression. So preprocessor is nothing but our column transformer, and the pipeline takes one argument steps, which is list of tuples, and in each tuple we will have two values. One is the identifier and the other one is instance of either preprocessor or the model. So that is our model. Now we will train and evaluate the model. To train, we are using X-train and Y-train, that is training part. With fit method we can train. So you can see we have trained the model. Now let's evaluate the model. So here I wrote a wrong message. Let's evaluate the model with R square score or accuracy. So R square score is the default evaluation score present for the regressor models. So with the score method applied to the model, we can evaluate the model. For test data, we got 99% accuracy. That's very fine and excellent. After this, we will save our model with job.dump method. Here you need to provide two things. One is trained model, another is the file path. Then we will save the cleaned data. To save the clean data, we have two CSV method. So I have saved the cleaned data with two CSV method. So let's save it by running the cell. After saving all the data and the trained model, we need to download them. So to download the trained model and the cleaned data, you need to visit the output section, and under that go to the working directory, click on the triangle. Now you will get two files. These two files are trained model and cleaned data. To download, click on the three dots. You will get a download button. Click on it. You can download from there the files. So after this we will implement our interface. So let's move to VS Code editor. In VS Code editor, we will implement our model. First of all, with Flask we are importing. So let's import the required libraries that is needed. So here you can see I have imported Flask, render template, request, Pandas, NumPy and job.leaf. So Pandas is for reading the data frame, NumPy is to change the inputs from string to numerical, and job.leaf is to load the model, while the Flask is for creating the interface. So here you can see I am loading the data frame and similarly loading the model, and then creating an app named with the Flask, then creating a route for home. So here we have different minimum and maximum values of different numerical columns, and then I have created a diabetes detector.html page to which I am passing these minimum and maximum values. Then we have created a route for inputs where user will post through a form, and if they post that, we will get that in the form, and that will be stored in these variables like age, gender, BMI up to glucose. So we will fetch the data. After that, with that data we will create a data frame. So as usually we know to create, similarly here also we do the same steps. Then we will use that data for prediction, and this prediction will be rounded and converted to percentage, and then again stored in prediction. So after that we will use a render template, that is diabetes output.html. Then we will pass that prediction. So here we have three templates. One is base.html. So here we using Jinja 2 technique. I have created a document with a title and a link, then a section. So that is basic or base template, using which I have created diabetes detector.html. Here we will have a form, so it is extending base.html, and we have title AI diabetes detector. After that we have created diabetes.output. Here you can see we have different inputs or select options for different columns. So these are created with HTML. Okay, so I hope you all know HTML, CSS, the very basic things. So everything is created with HTML, CSS and Jinja 2 technique. So this is the form, and form is available in diabetes detector.html. So with that we are providing these two inputs root, and then we have created output.html, and this is also extending base.html template, and here we will show the probability, and we also have a button go back with anchor tag, and it will go to the index page, the home page. So this is what our model is. So let's see some CSS. So these are the CSS that I have used in that model building or interface building. It's clear to all of you. I will provide this code in the GitHub section, do not be worried. So let's execute or run this application in our terminal to see or implement this model. So to open terminal, press Ctrl plus tilt and then write flask run underscore hyphen debug, and then press enter. After pressing enter you will get a link. So to click on that, press Ctrl and click on it, then now you will get the interface. So we got our interface. Wow, it is very nice. So here you can see I have entered age and selected the gender as male, and need to enter BMI. It should be between 11 and 53. So let's enter a value. Okay, let it be 45. Then need to select BMI category. So I'm selecting our weight. Then need to enter systolic values. It should be between 90 to 125. So let's enter 110. Then need to enter diastolic values. So it should be between 60 and 132. I'm entering 122. Then you need to select BP category, that is blood pressure category, and here I have selected elevated. Then need to enter cholesterol. I have entered 200. Then need to select cholesterol category, let it be borderline high. Then glucose should be entered, that should be 70 to 182. So I am entering 150. So So let's submit these values to the model. Let's see what percentage it provides. So here you can see in output we are getting 50% of probability. So to go back, click on go back. So thank you very much. Have a nice day.